Long one. All right, welcome class to tonight's lecture in the Cloud Solutions and API Integrations class in the Data Engineering track. This is class 6, Cloud-Based Machine Learning Service. I am Jeremy Bergman, your instructor for this class in Omaha Data Science Academy. Okay, so how is this class structured? So hour 1, we'll just take a general introduction to machine learning services and APIs. So machine learning services, you can think of this as software as a service, like API or REST APIs, or your programmatic APIs that you can use to create machine learning models. We'll cover some of those. We'll also cover machine learning services as a platform. So these are what we've been working through the whole class, like Microsoft Azure. There's some machine learning service that's in their platform is called machine learning, Azure Machine Learning Lab, or they're also now rebranding it as AI Lab. And then we'll cover some of those APIs that are in each one of those services. Hour number 2, we'll focus, like we usually do, directly on Azure Machine Learning Lab. We'll focus on building models, how to manage the building your model after you built the models, how you manage the life cycle of those models. So once you build a model, a lot of people think that's it, but really you have new data that comes in and you're continually trying to update and improve and make that model more accurate. And also on top of that, making sure it functions correctly. So Azure Machine Learning Lab has some of those features. And then we'll also see how we can deploy our model as a REST API or some other real-time API or something similar like we learned in class 2. Then hour 3, we will do a demo building a basic machine learning model using Azure ML, and specifically we'll use AutoML. They have a feature that will take your data and detect which model works the best on it, so you don't have to do any of that work yourself, which is kind of cool. So we'll check out how that works, and hopefully we get done early and we can cover any questions just so far overall in the class. Okay. So class 6 overview, just a little bit shorter than the other lectures, but still full of content. It said machine learning and AI services. We'll do that software and platform as a service. Platform as a service is really like that all-inclusive platform like we've seen with Azure, and not just a single tool, but a set of integrated tools that help with the whole model management of the life cycle. Then we'll see Azure AI and ML services. We always ask, what is it and why should we use it? Azure ML we'll take a deeper dive into the components and just like a general visual workflow of how it works. And then we'll do a demo using Azure ML Studio. Okay. So what are machine learning and AI services? So if this sounds a little bit like the rest of the class, it is a little bit in the sense is that you have cloud services that are, either software or platform as a service. But in particular, machine learning and artificial intelligence surface. So knowing both of those, they encompass a wide range of platforms and tools that enable individuals and organizations to implement, deploy, and manage AI and ML models. So one thing about the software is that software as a service, those are just generally models that you can connect to. There's anything from the models that you can connect to and use that somebody else has built, to building and managing your own custom models within a platform, like whether it's Azure Machine Learning or Azure Databricks is also within the Azure platform. You can build models within them too, build and manage those too. So they're really designed to streamline the processes with developing AI applications. a lot like Synapse Analytics was like the all-inclusive data engineering platform as a service. This is really meant to streamline the development of AI applications from data handling and model training to full deployment and modeling. So this is even intended to be a collaborative environment where data scientists create the models and data engineers help um, deploy and monitor and make those models more robust. So again, platform as a service. It's like Azure Databricks. Usually contains a workspace. You can do workflows. There's Apache Spark in it. You can build your own data science models and do your own applications like deep learning or streaming or out to Power BI and everything else. So for software as a service, I use the Google Cloud APIs. This is like an illustrative example. These are either like programmatic APIs or libraries in C# and Python, but they're also REST APIs. So like a Vision API is useful because that way you don't have to create your own model. You can just even send, depending on what the parameters of those REST APIs are, you can take an image, just send it up to the REST API as binary, and then it will return the result to you. So kind of like we've seen with REST API calls and getting back data, you could actually send an image to the Vision API, and then it'll return you some type of classification. The same is for speech API or natural language or translate APIs. And then they have a whole suite of machine learning services. So that's really like their platform as a service, but they have a bunch of different services, especially Google is high on the AI and the machine learning. So they have a bunch of these services intended for like programmers to be able to easily connect those to them and use them in their applications. So that's also the idea once you create a machine learning or AI model, is if you did it inside of Azure Databricks, you could deploy it as software as a service for others to be able to use it on demand. It helps, especially with the REST API we talked about being that general language. It really helps with being a generic standard to help communicate in between your model and other systems or applications. So that is how software is used and then platforms is used. So I'm going to break down each one of those. So AI and ML, software as a service. So software as a service is like you don't have to install your own software. You can use it as a service within the cloud that's already managed by some service provider or some entity, like a REST API. Maybe Box provides a REST API as a software as a service. So it looks like I didn't update this slide. It looks like the old slide. But basically, software as a service is just like what we talked about here with the Google APIs. I'm also going to bring it, since I forgot to update that slide. I'm going to bring up some examples of programmatic APIs in Python, and I should specifically mention machine learning. Let's just do AI. And I hate Microsoft Bing. I hate that I defaulted to that. So we'll go to Google. I started to do it for Copilot, and that's kind of useful, but Microsoft Bing has the worst search engine I've ever seen. Like legitimately, even worse than the early ones. Don't know why they can't do better with that. Okay. So programmatic APIs for Python. Let's do AI APIs Python. Then, of course, OpenAI has their own. That's one thing I should mention. OpenAI has their own. Everybody knows OpenAI with the generative AI. So they do it both, but you can connect to their REST APIs and send them little messages. You can send them queries and they'll return you the responses. Or they have programmatic APIs too. Sometimes the programmatic APIs are just interfaces to the REST APIs. So you don't have to do all the programming with the REST APIs, which is kind of nice. Or sometimes they connect directly to systems or software too. So another one I can think of, and I would call it a data science API. Let's do TensorFlow. So TensorFlow, what this is really a library, programmatic library to be able to create your own machine learning and AI models. So they have a bunch of packages, a bunch of different types of models that you can create. It's also a package that helps author machine learning workflows within the platform. So it's like an all-encompassing programmatic API. And I would call this software as a service because it's delivered as software. So there are things that you can use per APIs that you can use to create your own models. Another one that I've used in Python is called scikit-learn. I don't know if you might have used this in your other class. Potentially pandas and scikit-learn. This is a good example. I've used this library to build models before. Even as a data engineer, I'm a hobbyist data scientist at heart. Part data scientist, part data engineer. So they have all these different algorithms for like classification and regression and clustering. Even like reducing the dimensionality of your input variables and be able to do a job of running a bunch of models and doing model selection. So I'd also consider this like a data science API that gives you the ability to create your own models. With this, you could probably take this model and then put it in a notebook in Azure and deploy it that way. It may not have the tools directly to deploy a model, but you could take the code and install those libraries and then implement it in Azure also. So I consider the tools to be software platform, and within software, you have direct models that you can connect to, like your language, Google language, or Translate, or Vision. And then you also have these APIs you can use in Python or different programming languages to help you build models too. So that was the intent of that slide that I had here that I didn't complete. I did do this one though. So AI and ML platforms as a service. So these are like an entire like integrated platforms like we've seen through class. And platform as a service refers to as an entire platform that you can work from in the cloud. So when you think platform, I always think of like a foundation of a house. So like you have the foundation of your house, you have the entire platform, and then you have the house on top of it. So you have like all the tools to go with it. So something like Azure, you have some of the basics like storage and compute, and there are 4 of them that we talked about earlier. I can't remember them all off the top of my head, but they all build upon like blob storage and compute. And then you have all the different services that are integrated with it that help you out. So it's like the house of AI and ML, or the total integrated suite in the cloud. So they encompass a variety of cloud-based platforms and tools designed to facilitate the development, deployment, and management of AI and ML models. So all encompassing from development all the way to deployment and management of these models. It has all those tools. These three major platforms, or even four if you count IBM Cloud, they have fairly similar offerings with a couple different variances, and a couple of them are a little bit ahead of the others, depending on what your use case are. So the platforms also serve as a central hub. It's really about, like, with Synapse Analytics, like collaboration, where data scientists and data engineers can collaborate and manage and monitor all aspects of the model management lifecycle. I have a slide on the model management lifecycle. It's in Appendix A. I won't cover it too much here, but I have it there. The basic steps. I could take you to it. It's like the basic steps of model management. So data preparation, preparing the data just to be able to use it, training the models and building it, evaluating how good it is, deploying it, and monitoring it. So we're kind of covering it now, but it's an iterative process. And it constantly brings in new data, so you're always revisiting and improving the model and the life cycle, and managing the life cycle of the model, which these tools help you do. So it's good that these things come along because they continue to make data engineering, data scientist jobs more efficient. I don't know if easier is the right word, but it probably is the right word too, but definitely more efficient. So they typically include these things: data management and prep, model and training, deployment and integration, monitoring and maintenance. I looked this up on ChatGPT, and I just said, give me the major providers of ML and AI services. And they did Amazon Web Services, their tool is SageMaker, and specialized services. So Amazon Web Services has some really good programmatic AI and machine learning APIs for use. Azure has Azure Machine Learning. They have cognitive services for vision, language, and decision making. Google Cloud, I think they're typically really known as like the leaders in the forefront. You don't hear that quite as often. You hear that Microsoft has passed them up, but I'm still not entirely. Google's been doing it for a long time, like even before everybody else. So they have the platform, the Google Cloud platform for ML machine learning tests, and they have just a wide variety of like speech recognition and bots and text and conversation and stuff like that, intelligent agents, things like that. IBM Cloud was always known for Watson, for building and training models, and the APIs for integrating AI capabilities into applications. Honestly, I haven't visited IBM Cloud in a while. It's been a few years. Be interested to see what they have. Their famous one was like they challenged Watson to Jeopardy against like the top winners, and it lost at first, but they improved the model, and then it started beating all the top contestants who ever played Jeopardy. So, so that's saying something about their capabilities and the potential for AI, whether good or bad, depends on who's creating it, I guess, and what the purpose for it is. Hopefully good. Potential there is huge and good for it. All right. So Azure AI and ML services. So these platforms, they really aren't just a platform as a service. They also have all of these software as a service. So these platforms, whether it's Azure or AWS or Google Cloud, they're going to include a combination of platform tools along with these software services like Azure AI Search, Azure AI Content Safety. This one's kind of interesting. So monitor text and image to detect offensive and inappropriate content. So you could send the API text, and then it could tell you if it's inappropriate or images. That's kind of, you could imagine the applications for that. Translator, speech, vision, document intelligence, so they can extract like key themes and classify those in AI language. So they have all these auxiliary software as a service. They're usually intended for developers. So if you're developing some type of application and you don't have the expertise, or you don't want to create your own model, you can just go out to these services and be able to use them programmatically. So what Azure has, it has Machine Learning Studio. That'd really be their platform. It's a centralized place for data scientists and developers like we talked about. Azure AI Studio and Azure Open AI Studio. I realized that this is like their new offering in the last couple of years. Say I'm not as familiar with that, but I'm familiarizing myself quickly. It's a new web interface-based interface that allows you to interact with the Open AI service. So to either build your own models or co-pilot like generative AI applications. So this line between machine learning service and AI studios really becoming blurred. It's like all becoming one in Microsoft Azure now. And that development's over just like the last 2 years or so. Okay. So we always open with, in the second, we're already to what we consider to be the second hour. We always open that with like defining like what is the Azure related service, and like what is it, and then why would you use it, like what's the value behind it. So we're doing the same here. So what is Azure Machine Learning? It's that all-in-one platform that we talked about. This is actually going to look pretty similar to Synapse Analytics. So it's the all-in-one platform. Instead of data engineering, it's for machine learning and AI. Now it's becoming AI projects too. That's a studio interface. It's nowhere low code. So like using data pipelines and Synapse Analytics, now you can do something, you can do similar within Azure Machine Learning without having to write a lot of code. It's low code in the sense is that you can write your own code outside of Azure and notebooks and be able to create models that way too. So as automated machine learning, we'll see an example of this tonight. This is if you don't want to go through 30 different models, this will automatically go through all of the different machine learning models for you and then choose the best model to fit your data. So it's good to know how to have everybody here's taken the like model building and selection class and model evaluation class. So this helps you do like knowing all of that helps you do this. And at the end, they show all of your fit statistics and then you can choose the best model to deploy it. Machine learning pipelines is a similar concept to the data pipelines, Azure Data Factory, or the Synapse pipelines that we've done. They can manage the model lifecycle via workflows, can involve data prep, model training, model deployment, and then inference. So MLOps is just another word for like that whole, it's kind of like the fancy word now is MLOps, machine learning operations, but it's that entire life cycle that we talk about and being able to manage it. So whether it's like new data and then the all the way from the data preparation to like reevaluation and redeployment and monitoring. Does it from end to end, which Azure Machine Learning and other similar machine learning platforms do. So why Azure Machine Learning? Oh, especially this one. What's the value of it? Of course, it's a cloud-based service, allows the data scientists to build, train, collaborate, deploy, and manage machine learning models effectively. And not just data science. It allows them to build and train and do these things, but collaborate with data engineers. to help with this process. So you can imagine the data engineer's job is made easier. They can help data scientists with the data, manage the data, create these pipelines, make it more efficient, make sure the deployment of it's good, it integrates well, and perhaps even help them on with the model a little bit. I always think of data engineers and data scientists. They aren't mutually exclusive like the two circles on the Venn diagram that we saw at the beginning of the class. There's a little bit of overlap right in the middle, and that helps. It makes each other better in the sense that they know each other's domain a little bit, and these platforms help with that. So key features, automated machine learning through AutoML. All of the platforms have this now, some type of automated machine learning. Integrated with popular data science tools, whether it's like Spark or Spark ML libraries or those libraries that we just saw, like TensorFlow. Those are often integrated into these platforms. I can't remember if TensorFlow is integrated with Azure ML, but it has some other libraries that are integrated with it. Just with cloud, just in general, scalability and flexibility, Azure ML can help you with model interpretability. So this is the case so that the model is not just a black box that predicts things. You can actually tell what's driving the predictions and be able to adjust and monitor those models accordingly. And then, of course, continue to monitor them and manage it.
I have some questions around the automated machine.
Benefits for business. Maybe this is like the bottom line. Like, I love all this other stuff for the tech reasons. But of course, you have to convince, as a consultant, you have to convince the business side or business people of the benefits of paying potentially a bunch of money for a new service, or maybe not a bunch of money, but the cost of something versus the benefit, right? So benefits for business, it definitely accelerates model development and deployment. Even being almost new to this new platform, I was able to get up and running and build a model in about an hour. Cost-effective and scalable infrastructure, that's cloud in general. Productivity and collaboration, and then enhanced decision-making with actionable insights. So if that sounds like buzzwords, it is a little bit, but those are the buzzwords that business people want to hear. Decision-making and actionable insights. I've learned that along the way. That's it. Buzzword, business terminology. All right. So Azure ML components and workflows. So we're digging a little more into the nuts and bolts now of the Azure ML components and workflow. So there are 5 main components of Azure ML. You have data sets like you do, whether it's, somebody had a question. I am moving through this pretty fast. So let's take a moment to hit a question here.
You there?
John C.
Hey, I was...
John, am I missing your question here somewhere?
Are you there?
I can't hear anybody. No, that's weird. I actually can't hear anybody online. Do I have this muted? I restarted my computer because it was acting a little bit funny. Oh, you know what? My speaker's muted, or my audio's muted. Give it another try. Does somebody have a question?
Hey.
John C.
Yes. You there? Nope.
I still can't hear, can I? Let's see what the deal with the audio is here. Speaker. Let's try to do this through this. There's my audio. One more time, Ken.
You there?
Somebody screen. I don't know. Yeah, okay, now I could hear it. I was on the wrong input, plus I was muted. Sorry about that.
No problem.
John C., you had a question?
Yeah, on the previous slide. when you start talking about automated machine learning, how far does that go? Does it go to the point eventually where, they're just going to throw a set of data at it and say, analyze this data and tell me what you find? I mean, when you
Kind
start,
of.
go
So
ahead.
somewhat. So it will automate like all of those things if you took the model building class and evaluation, you may or may not have, but there's like a process to building models and trying a few different models on the data and then seeing what's best.
Right.
It automates that piece of it. So you can take your data, you kind of have to tell it just a little bit what you want it to do, whether it's like classification or prediction, like regression or prediction or somewhat. And you probably need the data set for it, but as long as you have like a curated data set, you can have it go through all of those steps. Now the other side of it, it still needs like at this point like a human to like interpret the results of it, right? So you have to look at it and say, do these results make sense, or is there some? If you're doing AI, you probably should have some type of safety involved. It's like, or is it actually producing like safe results or non-bogus results or something like that? So
Interesting.
both the interpretation of the model and choosing the right one, and then making sure it actually like works correctly in the way intended. So eventually, like maybe so many things will be automated that these you just toss a data set at it, and the AI analyzes the data set, or the machine learning, it cleans it up. Um, you tell it just briefly what you want it to do, and then it just takes everything for you. I think that's what they talk about. That's like the things that they talk about that like scare people is when like AI really starts like generating itself, and like it runs out of control from people. That's like the sci-fi movie stuff. But like these things become more and more automated all the time. It's like it's a little ways away, but like if it's like a fast slope on like the innovation or technology curve, it could be here sooner than later. I guess that's my rant, but John, is that kind of
Yeah,
what you were
it
thinking?
does. That just, you know, my fear is that it would take my job. If I, if I,
I think programmers are good for a while. I think for a long time you're going to see these things as your aid. That it's not just going to take like programming or system administration's jobs or some things like that. Things that are easily automated, that are easily like machine learning is based on like you teach it like a process and you feed it data and it automates like the obvious things. It's more like those things like manufacturing things that would probably be first. See it in like robotics or like self-driving vehicles and stuff like that. But even self-driving vehicles is harder because there's so many decisions that you have to make. And you have to make sure it's like the right decision in certain situations.
interesting. Thank you.
Um, but the things that are probably more manual or like repetitive, the more it lends itself to machine learning or AI at this case, in this at this point. But intelligent agents, if anybody's like really interested in that, like that's like where agents like start to talk to each other and then they list out all these steps to solve a problem and then they just go solve the problem itself. It's interesting. You just like give it its input. You basically, like I said, you just tell it what you want it to do and it goes out and solves it for you.
That is interesting because you get to the
So
possible point where they have if one machine can talk to another machine and each machine can distribute a little piece of work, then you truly do have a neural network, a pot that's potentially the Earth big.
yeah, and even bigger. To the thing that AI is like, you put safety. That's why people want to put safety rails on it to make sure those things don't happen. I think where it would get most out of hand is um, once it goes like beyond like the intelligence for humans to be able to like understand like what's even going on in the models. And like neural networks can be a little bit like that. So that's why actually model interpretability is like a big one. And then they talk all about building AI responsibly. That's like really the responsible deployment of AI models and how you're using it. So data engineers have a big role in that too. I wish I had more use cases to deploy AI models, but I haven't so far. I hope to do more of that in the future. A lot of times with businesses, they aren't even to the machine learning piece yet. They're just to the basics of like gathering and organizing their data and making sense out of it and building dashboards. That's like a good step one for most businesses. But you could find certain use cases for like pre-existing um, software as a service like this pretty easily. Like to do image recognition or create your own emails and stuff like that. I'm already trying to do that with generative AI and try to tone it on or train it on some of the emails that you create, so it has like a similar tone and style to how you would create emails. If you can tell, I'm a little bit of a geek about it. It's really fascinating. It's like when people call it like a new frontier of computing, I believe that. As much as the internet was in the 1990s and through the 2000s, or just computing in general. But it needs to be done responsibly. So almost all these websites, whether it's Microsoft or Google, they talk all about responsible AI, which is important to think about. All right, so long answer to a short question, but we have some time for it today. Hope everybody kind of finds that interesting, and you can do some of that with your newly found or as you continue to build on your data engineering skills, especially in these platforms that are designed for it. And to a point, you almost need these platforms because these machine learning or AI models are processing so much data. You couldn't possibly do it on one machine. There's some of those use cases out there right now, like OpenAI. They say is trained on basically almost the entire history of the internet. Of course, you probably couldn't get some of the pages from like 1995 that have been gone forever, but like the vast majority of the existing internet and some of the historical. So you need distributed computing and this type of services to be even able to create those type of AI models. That's sort of where big data comes into play too, which we only briefly covered in this class, but because they're often really specialized use cases. But they're out there. Okay. So we covered what is Azure machine learning, why Azure machine learning. We started to do the components of Azure machine learning. So I'm actually almost to the end of this lecture because I've been covering it so fast, despite my getting off track there a little bit, but interesting conversation anyway, and puts all of this into perspective. So components and workflow, this is where we dive down into the nuts and bolts of Azure ML. So the components, just like you'll notice this is similar to Synapse because this is like your data science, machine learning component of Azure instead of just the data engineering piece. So the data sets part is really similar. Those are the data sets that you create that are used for training machine learning models. Machine learning and AI models. You create experiments within machine learning. Those are being phased out a little bit in the new machine learning and AI AI studio, but this is how you basically do those tasks that you need to be able to build a model. So it's data prep, modeling, uh, model training, and evaluation. You now also have a model step. So this is where you create your machine, you model your data, and you create the machine learning algorithms from that model to make predictions. Then your component is web service. This is where you can deploy your service here as a REST, usually some type of API, whether it's real-time predictions or a REST API. You can do bulk uploads and things like that too. And then you have a number of tools for integrated development environments, for building, training, and deploying models. You also have things to be able to monitor them, to be able to alert yourself, and be able to see performance and everything like that. So the entire suite of tools or the components. And this is what a workflow generally looks like, just a generic workflow within Microsoft Azure. So this is actually gonna somewhat also, we talk about this class building in each other, putting all the parts together. So you see there the files that you put into the data lake, your ingest. You can put them straight into the data lake. You could use Azure Data Factory to do that also. Oftentimes, if you're analyzing it, you go to Azure Synapse Analytics. Then you can build and train the model in Azure Machine Learning. This has your entire Azure. It has your entire machine learning and AI model lifecycle that you can manage. So oftentimes you aren't just keeping the model there. So you'll feed it back to Azure Synapse Analytics. So you can do that within a workflow within Azure Synapse. And then you can visualize the results and performance by Power BI. So oftentimes when you're deploying a model in Azure Machine Learning, this goes out to like DevOps, or it's a REST API, or you could even deploy it to like virtual machines and stuff like that as its own application. So when you're deploying it here, it's usually then intended for other applications. If you do it, send the results back to Synapse Analytics, you're usually visualizing the results in Power BI. Both are important because it's important to not just build a model and assume that it's going to work well forever. That's one of probably the things about AI or machine learning that people have to be aware of, is that not to allow their models to run out of control, is to be able to continue to feed it with new data or relevant data, and then make sure, like, after you build it, that it continues to make the predictions you want it to, and it doesn't like start to get out of hand and so forth. So one of these they considered, so a story of this going like way back is, so financial quants during the 2008 financial crisis, they built all of these almost like predictive models for these mortgage-backed securities. And their models worked for a long time until like the conditions changed. So like unemployment, like the economy crashed a bit. Well, it's actually due to mortgages, but there are two things with it. Is that one, they underestimated like the current unemployment rate, and then two, they underestimated the risk of the mortgage-backed securities that they're creating. So they ended up being a lot more risky than their predictions made, because they started to put all these new securities and financial products together. That backfired on the banks until a couple were caught with all those mortgage loans and went bankrupt. And of course, that led to banking crisis in 2008. I was there for that. It's interesting. Interesting time. I was young, so I wasn't really after I had to lose my job. They weren't really paying me anything to be there. But that's a case where models, you have to continue to monitor them, and like maybe they aren't creating the predictions that like continuing to, like they started to do exotic things, and maybe those predictions weren't that valid anymore, to continue to monitor them so you don't have things like that happen. That's one of the more extreme cases, but you could imagine that with AI also. Like you don't really build these things, even if you did self-driving cars, you'd have to continue to monitor the model, constantly monitor them and make sure they're doing the right things, which can be scary, but at the same time, it can also be, if everybody's following the same rules on the road, it can be vastly safer too. So like some of the edge cases sometimes are making sure that these models do what you want it to do is why you continue to monitor them. It's a very important part of it, part of the life cycle. And it'll also be part of the project that we do in this class also. Okay. So this is actually the last, slide and video of the night before our demo. So I'm going to go ahead and play this. It's about 15 minutes long, and then we'll let everybody take a 10 or 15-minute break after that. Be about 7:45. I'll go through the demo, and hopefully we have some working time here at the end of class. I'll cover any of questions about the homework assignments. I'm still behind on quizzes, but I'll also start to talk a little bit about the rest of the class and what the class project looks like. It'll be about 7:45. This is 15 minutes, and then we'll take another 15-minute break after that. So go ahead and get this started. Let's see if I can play this from the slide today. Probably not. So I'll go ahead and pull this out. PowerPoint slide. I always point everybody to them. I always put them in Google Drive and then point everyone to the links in Google Drive. I didn't need to just send out the PowerPoint, but everybody can use Google Drive, and not everybody has PowerPoint either. So I can't win. That's okay. Okay, enable content. Go ahead and copy this link out of here. I think I have to play it for half a second. This is a pretty good video on how to build and deploy the life site, or build a model from start to finish in the new machine learning and AI, Azure's new machine learning and AI studio with AutoML. I'm a tech guy at heart, so whether it's cryptocurrency or financial technology or AI, I love all of it. All right, I'll pause that and shift over to that screen. So present. Build, train, and deploy machine learning models. All right, thanks for the patience, everyone. I am on the building connection here tonight, so let me know if you have problems, if it becomes choppy, or if you have problems. And I can let everyone have a break and switch connections, but we'll go ahead and give this a try.
Hello everyone. Let's see how we can build, train and deploy a machine learning model with Azure free account. So first and foremost thing, you need to go to
It's kind of
azure.microsoft.com
frozen, so I
in the
actually
machine
can't
learning
hear
and
it
create your
myself either.
particular free account here.
Can anyone
So once you
online
do
hear
that,
it? Probably
you will
not.
get into a dashboard or a machine
We
learning
can
We
hear
studio
can
it.
like
hear it.
this, which is
Did I lose?
ml.azure.com. And when you get into the studio,
Lose everyone online.
the first and the foremost thing is you need to create your workspace.
My audio is going
So you
crazy
need to
today.
click here on the create workspace button.
Okay,
Enter a workspace name, say demo,
there we go. The audio
trial,
is going. Can
or
everybody?
something like that.
I'll restart.
And
We can
then
hear
you
it.
can select the
I
region.
didn't hear the first.
Let's see
I
how
didn't hear
we
the
can
first minute of it. So I'll go ahead and start it from here. Everybody online, can you hear it?
Yep.
Okay. I'll go ahead and
build,
go
train,
ahead
and
and go with
deploy
it.
a machine learning model
Excuse
with
me.
Azure free account. So first and foremost thing, you need to go to azure.microsoft.com in the machine learning and create your particular free account here. So once you do that, you will get into a dashboard or a machine learning studio like this, which is ml.azure.com. And when you get into this studio, the first and the foremost thing is you need to create your workspace. So you need to click here on the create workspace button. Enter a workspace name, say demo, trial, or something like that. And then you can select the region where your workspace will reside. So you can select, Australia East or East US, France, Japan West, etc. In my case, I'm selecting Central India. So you need to click on the create button here. So once you create your workspace, it will be something like this will be seen here in the studio directory. And then you need to click on your workspace. So once you click on your workspace, you get into the home dashboard here, right? And in order to build any model or consume any model, the first and the foremost thing is you need to specify the data that you need to train this model on. So on the left hand side, go to assets, then go to data. And here you need to upload your particular asset or data file. Okay. So in our example, I'm going to upload this particular training dataset. This is something I have just created randomly. So basically here we are going to look at a use case where a banking software or an application needs to decide whether it has to give the loan or refuse the loan. So in this particular data set, you can see that it is taking details like what is the current loan amount, the term of the loan, the credit score, the home ownership, what is the reason, the annual income, the purpose, credit history, months since the last debit, and then current link balance, and then any sort of bankruptcies that were there. So this is the data set I am uploading. So to upload a data set, you need to just say create and select the data set name. Let's say banking loan dataset. Okay, and you need to select the type here as tabular, and then let's say next. Now we are going to upload the file from a local file, since I already have this file on my local machine, but you can also import it from an Azure store, SQL database, Azure Open Dataset, etc. So let's click on from local files and then say next. And then here, let's select the default data store, which is Azure Blob Store, and the workspace. And let's say next. So here we're going to upload the file. Make sure the file is a CSV or a TSV or has JSON line or plain text. So let's upload the CSV file. So now I uploaded the CSV file. I say next. And it now validates the file. So here is, you can automatically preview the file, whether it's uploaded correctly or not. Okay. Everything seems okay. Let's go ahead and say next. Here you can see the schema that, okay, my loan status type is a string, my loan amount is an integer, etc., etc. Right. So you can see all of these fields here, right? So if you try to compare it with my data set here, you can see here, this is the string, this is a string, and the same captured over here. So let's say next. Now we just review everything, and then you can say create. Okay. So once you do and say create, it is automatically going to add that data set for you. Okay. So I'm not creating this file anymore. So I'll just say leave. So here, once you have created your data set, it will reflect in the data assets. Okay. So once you have added your data asset, the next step is to add a compute. So go here into compute, and you can create a compute cluster. So you can click on compute cluster. I've already created one cluster, but I'll show you how you can create your own cluster. So you can say new here, and then you can select the location where your compute cluster should reside. You can say virtual machine type is dedicated, and your virtual machine type is CPU. And then here you can select the category and the machine size. Okay, once you're done, you can just simply click on next, and then fill in the compute name, whatever name you want to give to this cluster. Demo cluster, right? Create all the default settings and then say create. Okay, I'm not going to create another cluster now, but once you create a cluster, you can see that it will reflect in the compute clusters here. So step 1 is done, which is we have added our data. Step 2 is done, which is we have added our compute cluster. Now let's go to step 3, which is to automate the machine learning algorithm. So how do you create an automated ML? So just click on new automated ML job. Okay, give it a job name. Say anything, bank loan status experiment can be the same thing, which is bank loan status experiment. Okay, so you have an experiment, and then within the experiment you have this job, which is bank loan status. So you give this setting details, you say next. Okay, now here you needed to select the task type. So our task type is classification, which is specifically to say, whether the loan status is given or the loan status is refused. So there are various other task types as well. So in our case, we are going to select task type classification, right? Here we are going to then select the uploaded data file, which is the loan processing data file, and then say next. And once you're done selecting the data, now you need to select the target column. So target column here is basically loan status, because this is the target column we want from the ML algorithm, whether the loan has been refused or the loan has been given. Okay, so there is view featureization settings, right, which will give you all the columns that are added in the dataset. And then you have view additional configuration settings here. So in our case, we would like to select the primary metrics as accuracy, right? You can select the primary metrics. There are various other ones here. So we want to be very sure whether the loan is given or not. So hence we are selecting the primary metrics here as accuracy. You can read more about this using this particular link here. Okay, so we change the primary metrics to this, and our positive label class. So our positive label is when the loan is given, our positive label is, it is a positive label basically. So we select loan given here as the positive label, right? The negative label will be loan refused. So we do this and we say save. Okay. Once you have added the view additional configuration setting here, you can click on next. You can select your compute type, which is specifically the compute that you created, which will be compute cluster. And then here you can see this particular compute cluster to be created. And then you can click on next, and then you can submit your training job. Okay. So once you submit your training job, it will take a couple of minutes to skim through and decide the best suitable ML model for you. Okay. So click on submit training job and wait for a few seconds till all the jobs are run and vetted. Okay. So I'm not creating this right now, but you can always go ahead and try it. Okay. So I'm going back to an already created job. Once your job is completed, you will see the status as completed here. Okay. So you will have to wait till the status is marked as completed. Right. And then you can dive deeper into which model was the best suitable model or which algorithm was best suited. So in this case, you can go into the models plus child jobs tab. And here we can see that sparse normalizer, algo, and XBoost classifier has got a really good accuracy for us and 100% sampling result. So let's go with this. Now in this particular algorithm, you can always test the model. You can click on this particular thing, which is test model preview. And you can add your test data set here and test whether the model is working as per your expectations or not. Okay. Once the model is tested, you can always view the test results here in the test results preview panel. So I have done one of the tests here, which is showing me an accuracy of 0.99. And here you can see all the metrics and relevant details related to that particular test. Okay. How was the accuracy, the correlations, etc. Okay. So once you have decided like which model best suits you, you can always convert it into a particular and deploy it as an endpoint. Okay. So say I have selected this model to deploy. You can click on the deploy button here and say deploy it as a real-time endpoint. Okay. So once you click on deploy as a real-time endpoint, it is going to automatically deploy it. Okay. So here you can just select the endpoint name. You can say demo bank status endpoint. Okay. You can give some deployment name and then you can just click on deploy option. Okay. We already deployed one endpoint. Obviously, it will take a little bit of a time to get it deployed, but you need to be patient and wait for it. So once you have deployed the endpoint, you can get into assets and endpoints here, and you will see the endpoint getting deployed over here and created over here. So you can click on the endpoint and you need to wait for the deployment state to be healthy. This may take a minute or so, so you need to give it some time for the deployment state of the endpoint to be healthy. So once this particular endpoint state is healthy, you can consume it and you can test it as well. So let's test this. You can input any particular parameter here, and then you can test this particular thing, right? So in the processing model, you can test your endpoint. You can simply say test, and it's going to tell whether the loan is refused or the loan is given, right? You can also consume the endpoint here and simply copy the Python code or the C# code, etc. Right. So I've copied this particular Python code already. So let me open Visual Studio here for you. Right. So I have consumed this particular Python code, and then I have just changed the data over here to some data set, right? So this is 2149, long term 666, etc. And then I'm running this particular model and trying to see what the output is. So let's run this model, which is LLM1. And then here you can see as a result that the loan is refused, right? Now I've put and copied the same code to another model where I've changed the data, right? Which says short term 1771 and credit score, credit history, etc. And I'm going to run this again and see what it is giving, right? So here you can say that the result is loan is given, right? So this is how easy it is to deploy an LLM model and then consume it in your relevant applications. Thank you for watching. Hope you like this short demo.
So that last part's a really good example of how you can deploy the model and create a REST endpoint. And then within Azure Machine Learning Lab, you can feed the model data or parameters, like we learned with the REST API calls, to be able to test the data or to be able to send it data and then it reply to you with like a prediction or a response. And he did that through a form in Microsoft and Azure ML Lab. And then he did it with Python code. He called the REST API by Python code and then was able to use it that way. So super common way of deploying machine models or machine learning and AI models as a service. Oftentimes it's like they'll call these microservices. So they do like a small function that you can call. It's almost basically a type of microservice that you can with these AI and machine learning models. A microservice you can call in a program to use some specific functionality for you, or give you back a prediction or recognize an image and so forth. That's a good example. It looks like my model's completed from earlier. It took like an hour to run my models, auto ML models we created. But we'll give it our best here, the walkthrough. We'll do that about 7:45. So let everyone take a break and we'll give this a shot ourselves. I was just talking to Brenda about this and the Microsoft certification exam, and looking over the certification exam, and there are lots of questions about engineering optimization, like what type of pools you should use or redundancy based on workloads, security questions, and stuff like that. So we're really just scratching the surface in this class, but hopefully I'm giving you a pretty good overview of where to get started. At the end of this class, on the last day, I'll point everybody to resources that I would have liked to cover in this class, but we're already covering quite a bit of ground. Plus, we got to learn how to use REST APIs in this class too. So that was part of the learning, and that's not included in the data engineering exams. But I feel like this class in particular, it's like the movie you watch and you loved it the first time, but you didn't quite catch everything. So like the second time you go through it, you're like, oh yeah, that makes sense now. It's kind of like you put it like all together for the first time and you're like, did I miss that somewhere in the movie? And then you go back and watch the movie and you're like, oh, I get that now. So hopefully everybody rewatches these videos. That includes me re-recording the exercises for lectures 3 and 5. So I didn't realize lecture 3 didn't have any sound to it. So I'll work on that. But I recorded lecture 5 today and I have the same issue. So I'm 0 for 2 on making sure the volume's on. So we're just fine in these StreamYard classes that we're doing, but for whatever, I must not be hitting the unmute button and then I just talk through it. So I've recorded them, but they don't do you that much good without the sound. So I still have that work to do. Still have quizzes to go through, and maybe we can, I'll introduce the final project tonight, and then we can try to answer anybody's questions. For Monday, I hope to like really have all of the content together so I can just walk everyone step by step back through the class, like the homeworks and things like that and how everything's put together. And then we could ask questions about the projects and anything we want to do, anything we want to ask questions about or work on. I want to do that as like a recap, like everything that we covered and how it now like that movie where you're going back through it and then you like see all the parts, makes it all so it all like fits together and makes sense, because that's what I intended to do with the final project, is like put it all together now to help you with the final project too. I think it's a good plan. Thanks everyone for providing like feedback and everything along the way, this being the first time. I think we're doing a pretty good job of like adjusting things for the first time and learning. And there's some things I've had to cut out too, just for the sake of time, but we're getting there. We're headed towards the end and I'm feeling pretty good. I feel pretty good about just knowing the different components of Azure, knowing like cloud engineering in Azure and your different options, how REST APIs fit into all of that, and being able to engineer a pipeline from start to finish is like really the goal. And then you could rewatch the videos and rewatch some of these exercises and then take that with you so you can like just keep building on those skills. That's the goal. All right. So I'm going to go ahead. Oh, man. And we'll go ahead and get started with this demo. This machine learning lab model, or machine learning lab model I created and just deployed. as we were at break. Go ahead and unshare the screen. Stop sharing. Go back to this lecture and then put machine learning labs side by side. I mean, making the lecture earlier and even doing a couple sidebars, we got to the third hour right on time. Even started at like 7:20 or 6:20. Have to keep that in mind. All right, so the class exercise. So it's gonna follow that. It's gonna somewhat follow, well, more or less follow that example that we did. I did it in just a slightly different way. What we're gonna do is predict the future total market cap of cryptocurrencies and then deploy that model. So I took it, my steps are slightly different than his, but it still ends up getting to the same result. If this seems like a lot right now, it is because I just got these down on paper. But hopefully walking through this demo is gonna help make sense, a little more sense out of this. So there's one file I did create for this. I expanded the fact overall history data set to be able to create a model with it. So I'm going to go ahead and drop that in Slack so everybody can look at it and try to reproduce the same results. If you'd like to follow along, I'll go a little bit slower through this example too so everybody can get this piece by piece. Go to documents. Hold on one second. Gotta get this file. Okay. Gonna drop it. I've got it here to overview history. I'll pull it up on my screen here in a minute. I don't think I'm sharing this other screen yet. Need to make sure I'm doing that.
Yeah, you're not sharing at all right now.
What's that?
I was just saying that you're not sharing at all. Yeah, now you are. Yep.
Yeah, I just realized that as I was going through the class exercise. So yeah, we're going to predict the future total market cap. Here's the instructions. This is the way I did it. That's a little bit different than the video. It doesn't make a whole lot of sense right now, but as we walk through it, hopefully it makes a little bit more sense. And I have a file here that I'll drop. Updated. So it's the overall history that we've been working with, but I extended it. I got more data and extended it back to the beginning of 2020. And I also calculated a couple of different columns to build this model. So this is updated overview, crypto overview history. For ML lab. Okay, I just put that in the cloud engineering channel and I'll show everyone what I did here. Okay. So some of these columns are going to look familiar. From date all the way to the day overall. I wouldn't worry too much about these because I use those to detect duplicate records in the file. But I created these other additional calculations for prediction. So I did like a change in market cap over 10 days, over 30 days, over 90 days, and over 200 days. Those are types of variables like you usually use to try to predict future prices, like your 10-day, 30-day, 90-day, 200 days. So I was trying to keep it simple, but I was trying to do something relevant for machine learning lab, that was kind of quick and dirty. You could also calculate these in pipelines and stuff like that, but since we're just doing this as an example, I just calculated it right in an Excel sheet. So this is the data that we're going to use. I dropped that into Slack channel, and I'll go through these steps. I want to pull this one over to my screen, and I'll bring up Machine Learning Lab. Okay, whichever. I already have most of my tabs back open. I have to figure out which one it is. Yeah, let's go ahead and do this. You can go to ml.azure.com. Right now it's combined AI and machine learning studio, because they're integrating a lot more into it. As I put together this lecture, I assumed that it was still the same as it was 2 years ago, and it's very different than it was. So I did this on the fly a little bit. I had no idea that Microsoft had changed it so much, but in the last 2 years is when the AI wars are really taking off and everything like that. So maybe I shouldn't really be surprised. Not really surprised with the rate of innovation on these things. Not expected either. Okay. Go ahead and let this load. So the first thing I did here was go straight to automated ML. We're going to take that data set. We're going to let this automated ML try a bunch of different predictive models on that data to try to predict the total market cap. And we're going to go through these steps. But we're going to let Azure do the job on these. So of course, when you get in here, you'll want to do your new automated ML job. I already have a couple that I created in here, but definitely worthwhile to take you through these steps. So what I did is create a new automated ML model. So you see this is going to be the same screen that they showed you before, more or less. You have some steps that you need to take to automate this ML job. So a little more, this one's a little more involved than most, like Synapse Analytics or Azure Data Factory. There's quite a bit more that you need to set up. I would just go with this default name, job name that they do. They'll give you like a unique job name. An experiment name, you could use an existing experiment name. That's where you create your models. That was one of the main parts of the machine learning. Machine Learning Studio for this platform. Let's go ahead and create a new experiment. We can call this whatever we want, but I'd probably call this like I have on the slide. This seems to be really picky. This one seems to be really picky about the names that I give it. But let's try to copy this one out of the slide. So if I do coin overview history, we're predicting the total market cap and then put my initials on it. Always like to give as descriptive names as possible. It helps future me sort things out when I'm looking through it, looking back through all the different models or pieces of code that I create. Right. Task type. So for this one, it's not really a yes/no classification. You could use time series forecasting on it. I did regression. You can do a regression model to see what the main factors are in predicting the total market cap, and then make predictions using regression. Then there's some others if you have text, natural language processing, but we won't do that. And computer vision is like image classification. So it would say if you send it a picture of a cat, it would tell you it was a cat or maybe a dog, depending on how much it looked like a dog. But
Hey, Jeremy.
selecting task type, regression.
Hello?
Can you hear me?
Yeah.
Am I off? Okay.
Hello?
Let me know if you can't. I'll speak up here a little bit. My computer's still acting a little bit funny. So we'll go ahead and select data. We did basic settings. Gave it the new experiment name. Doing regression for prediction on this one. Select data type. Select data. We'll create this. Data asset name. I just give it the same name that I just put in there for the model name, or whichever one that was before. This one I chose tabular, I believe. Tabular version 1, I believe. Let me double check that. That's what I seem to get to work here without too many problems. I'm just double checking that in my notes. Okay, type tabular. Since we have a local CSV file, we'll do this from local files. Of course, you can see you could do it from a SQL database or Azure Blob Storage, or you can even get it from a REST API or Azure Open Data Sets. They actually, interestingly enough, have a big library of data sets that you can use along with this stuff, which is also neat. But we'll get this one from local file. So you could get it from the data lake. I just did it from blob storage for now. They create a new data source. I did not. So I am going to recognize I'm going a little bit faster, so I'll slow down and let everyone catch up who's following along. Say, Brenda, how are we doing? Going a little fast?
Well, originally I didn't have a workspace created, so I do that first.
Okay.
And then
John, you can still hear me, right?
I can. Can you hear me?
Yeah, I can hear you.
Okay. So it took
That's
me a
good.
while to get the workspace created. And so can you go back to your data source, your step 2?
Yep. Okay. So I went here and I went to Azure ML after you create that resource. I gave it this name. You can name that whatever you want. Then you had a destination story. It's type tabular that we're going to import. Let me know if you can't find this part because I think I might be skipping a step here because we chose regression and everything. You want me to go back to that?
Yeah, to the 2 again.
Okay, so I went to automated ML.
Basic settings, on your basic settings.
There's a train automatically in basic settings. Okay, no problem, John K. So these are like all the basic of the submitting an auto ML job is that it takes you through this like it did in the other video.
But you're on 3.
Yeah,
I need to get to 2. I need to go to basic settings and see what's there. Create new.
So the basic settings, I would just keep that job name that they give you. They give you a unique job name. The experiment name, I did create new. And then I gave it a descriptive experiment name because experiment was like one of the main components of Azure ML where you create your models within a new experiment. So I gave it descriptive of the data set and what we're trying to predict, and then my initial.
Okay.
They just keep giving me the thumbs up here. So next type. So since we have cap and it's continuous variable, and then you have your other predictor variables, I chose regression. So you could use regression for prediction on this. They do have time series forecasting, which you could do also, but regression will tell you which things are the most important factors in predicting market cap based on what we decide to feed into it. So it's regression. So selected data was like where I was just leaving off. Data asset name, I would just give it the same name as the project, or if you even wanted to shorten it up. You could do coin overview history and then your initials. It imported as type tabular. It seemed to work well with the version 1 APIs. That's what I got to work in this one. No particular reason, just trying to get it to work. So since we have that CSV file, we'll import it from local file. So I believe when everybody configures this, the Machine Learning Studio gives you Azure Blob Storage with a couple of default Azure Blob Storage. Does everybody, once you get to that point, do you also have this too?
Yeah.
It is?
Yeah.
Lucky enough. All right, so I went ahead and used Blob Storage because it's already set up for me. I didn't try to connect it to the data lake because that can be its own monkey. So I just chose Workspace Blob Store. Take you choose file or folder. Upload file, so I'm going to choose that CSV file. Fact overview history that I dropped to everyone in Slack. I have it on my desktop or in a folder on my computer. But if you download it and point to that, all right. You can see the file types it supports, so CSV is good. I don't think it could already exist in there for me, so I'll do override if it already exists. Hit next, that'll upload it to that blob storage. So once you get there, settings, it starts to automatically detect like the columns and data types and everything. This is a good step to make sure that everything imported properly, given like the delimiters and the codings and the headers and stuff like that. Yeah, all of it looks good.
This is like the first, like, 5 tables from the spreadsheet, right? Like, it's the first couple, it's not just random.
Yeah, so from the original API that
CSV.
you're talking about, from the original CSV.
Yeah, it's like the first 5 or whatever, 10.
Yeah, they were like the original ones, and then I've added these other columns onto it. So that's why I dropped the other one in, because I added a couple of these columns in, just for like the types of variables that you would use for predicting market cap, like market cap percent change the last 30 days, or 60 days, or 10 days, and stuff like that. Right, tell you some of the things, a couple of the variables you use to try to predict it. Okay, I think you could hit review here if you wanted. Oh, let's actually go back here. because in the scheme, we want to go back. We don't want to review all of this. That took me to the end. So schema, what we want to do is we want to choose the columns that we use out of this file. So I'm going to take a couple out of these. I just really want the variables that I'm going to use for this predictive model. So we'll do cap, keep BTC dominance in here. So this is like what percentage of the market cap is captured by Bitcoin. Take out cap overall, date overall, and there should be a couple more variables down here.
Juke. Okay, Juke.
There we go. Okay, scroll down there for a second. Panicked. All right, so then there are these last cap percent change, 30, 60, 90, 200. Just keep those, the ones that we want to use for prediction. We're predicting market cap, and these are predictor variables, what we're trying to predict market cap with. So like our explanatory or independent variables, caps are MBTC dominance, and caps like our target variable, what we're trying to predict. Okay, then it just reviews all the settings. Let's go ahead and create this. Okay, so if good, the coin overview history JB data asset is created successfully. That was step one in creating all of this. So once this is done, actually, it's creating the data set right now. So I think we have to wait till this data set is created until we can go to the next step.
How do you know it?
Usually it gives you, in the other ones, it gives you a little notification here.
I mean, mine's a success.
So it looks like it created, but it never gave us another update. I do want to go back to those. Oops. Oh, dang. Okay. That's not AI, it's sorry. I'm back, and I'm back.
The green thing, it does say it may take a few seconds for this to be updated.
So I'm going to go back to that workspace, that experiment, AutoML experiment that we created. I think disconnected me there. Service. To be, as I was going through this, I was thinking that Microsoft has some work to do on this machine learning platform, but with everything they do, they're always rapidly improving. So there are other platforms that do the same thing. We covered Azure Databricks. That one is perhaps like superior to this at this point. We don't cover Azure Databricks. Contemporary Analysis likes to use a tool called Dataiku. That has like a lot of the similar features. You can create notebooks. You can create analytical pipelines. You can share and then deploy and everything like that. So a lot of these tools are like this. I think this is like a step behind right now, but I would keep looking at it to be a competitor. Like Google has like an ML lab that's pretty good too. This one seems like cumbersome and not quite like on par with their more sophisticated tools yet, but it's an up and comer. Where did my AutoML job go? Okay. I'm gonna refresh.
So I opened another window to see, mine doesn't even show up either.
Okay, let's go through this real quick. So let's go back. Great job. AutoML. Create a new AutoML job. I'm going through this quickly. The experiment name. If this says it's not a duplicate, it must not have saved the last one. Task type, regression, select data, data asset name, type tabular. When I backed out of it, I must have just lost it, which isn't so typical of the other services either. I think this one's a bit of a work in progress. But it doesn't, this AutoML was really simple and it makes, you see when you get to deployment, makes it really easy to call this through data set, data asset, mobile file, user blob storage. Factor review history, override if it exists. Going faster than my computer. It's uploading. This is just creating the data asset piece. So if I get through this, it should take me through the rest of the machine learning AutoML process. Just need to be patient and not hit the back button. Oh, that looks good. We're removing the variables that we don't need for prediction. Liquidity. I thought about using liquidity. What are there? That's all of them. I just want those. The percent changes. Creating data asset. Great. Refresh. So I must have missed it here. This must be the next button. Nope, not cancel the job. That's not.
You have to select one.
It's showing it.
So select one, select the, yeah.
Okay, it's created. Okay, if he selected, then it goes next. That's what I was missing. I forgot that step. You have to select that data set that you wanted. If it's existing, you can just use it, or we created a new data set. Okay. Target column is cap. We want to predict market cap. Validate and test. So you can, so in predictive analytics or machine learning or AI, you're really creating like a mathematical model. You want to create it on part of the data and then test it to make sure it works on the rest of the data. And make sure your model is valid. So yeah, validation type, I'm just going to do the default settings here, but you can train and test and do this in a bunch of different ways. I'll just go with the default settings just for this time around. I'm not too picky about it. All right, they want you to set up a compute for this. Do serverless, we want them to do that. You can set this to higher virtual machine. I would kind of like to do that because this took an hour for me to run this. You have plenty of credits too, so we'll set it on the biggest one. I think we probably do. Set it on the most expensive one. Still, even at that, these aren't too expensive. Let's go ahead and set this on the most expensive one and see how much faster it goes. Number of instances. So you could scale up to more than one instance. This is such a small data set that we won't do that.
So it's 60-something cents per hour?
Yeah. Yeah, that won't even make a net in the for $203 that you have. I think so far in this class I've used like $4 of that $200 from what we've done. I think you have 6 months or 1 year to use those credits. Can't remember. 6 months. That's okay if you pull down compute. Even if you don't find that, I would just do the most expensive.
Okay.
Okay. So it hasn't started yet. So let's go ahead and edit this. Oops. Maybe it didn't launch there. This is where we were at, Brenda. Is that the virtual machine size? I select the biggest one. There's one in here. It was like 60 cents an hour, but I don't see that one now.
Yeah, same here. So I got 30, I think I got 30 some, 38 maybe was last thing I saw. Yeah.
I think I might have a training job running here though. Yeah. So after I did all that, I submitted the training job and now it's trying to run all those models on it. This may take a while. I just used like the default one before and I launched it at like 4:30 and it was just finishing by the time we got to class here at 6 o'clock. I thought it'd be a lot faster than that because it's a small data set. But it's trying to do all those different models and then do all the validation on it and everything. So I guess it takes a while. All right.
So
while that's running.
I got a 404. That said job doesn't exist.
A 404. Job doesn't exist. So you went through all these steps and it says submit, you got the submit training job?
Yes. Oh, and now it says
Can you
status
hit that
running.
and
When I
then
try to go back into it, it says status running. Huh. Interesting.
That's why I'm saying, yeah, this the Azure Machine Learning Studio is like that a little more than the other ones. I noticed that as I was going through it. That's why I'm saying it's still a little bit of work in progress. But you can come up here like you do in Synapse Analytics and see what's running, and you can see the job details. So what's good about this is like Azure is highly integrated, and like we saw in that workflow, once you have this job, you can run that in a data factory pipeline or a Synapse Analytics pipeline if you wanted to. So while that runs, I'll show you the results I got. I think this is not great now. It's just setting up the run and am I a couple minutes into it. Started on 8:23, so I'm like 3 minutes into it. It takes a little while. So I'll show you this job that completed for me earlier. It was this one at 5:10, where I submitted it at 5:10. Completed, actually it took longer than that, so it's 5:10. It ran for an hour and 42 minutes. So it completed about 7 o'clock. But once you go into this, you see a few different options. It says the status completed successfully, what data asset you used. Here's the best model and everything based on its model statistics, the fit statistics, what algorithm name it is. I've never heard of standard scalar scrapper, so it's kind of cool that it tries that model on it. So if you want to know a little bit more, you can go to that specific model where there's a list that it'll show you a list of models that it tried. This will give you the fit statistic for regression. It's root mean squared error. This one, I think, it's the best one. It's a little suspect because it has 0, so it says it's perfect prediction. But you can view the explanation on some of these, and then the metrics and so forth. So this is where it really still takes a person to say, like, okay, the AutoML created models. Is it really like a valid model, or is it a good fit, or is it something we should deploy? You can even see now that with Microsoft, they're doing like responsible AI inside of this. When you create like a new AI algorithm or model, I have no idea what this actually is, but it must be some type of, I couldn't even tell you how they would measure responsible AI. Have to read a little bit more about it. But you can see the model. You can do model performance. The R² of 1 is suspect. Nothing's ever like a perfect prediction unless you put the wrong variables in, which I actually did in this one. I accidentally put the aggregate feature. I accidentally put the cap overall in there, which is a perfect correlation to the market cap. So it used a variable that's a perfect correlation to the target, which I didn't actually want that to be in there. So you guys should get a better model than that. I ran it, and then I was like, oops, I accidentally left that variable in the model. So what I would do is go back and take it out and rerun it. But just for the sake of this example, we're going to go ahead and say, ooh, we have a great model. Let's go ahead and deploy that. So it gets through that. I want to say it was this one. Yep. You can click on that. You see the deploy option comes up. That was cool. So now you have a real-time endpoint. So if you're doing like real-time data, is that this would be like, can't think of the name of that endpoint right at the minute. That REST API type that we went over, that's a real-time endpoint. They designed it that way. With the idea that you're sending it, you're connecting back and forth real-time data. You could do a batch endpoint where you send batch data to it to like update records or get data back in batches. I did just deploy it as a web service. So this was an example that they showed where you could send it like a single observation and some parameters and data and it would return the prediction to you. So I did that. They'll just ask you a couple of different things, your compute type and your compute name. So I made the point to Brenda is that this is basically what REST APIs are. They run on like a web server in the background. It's all on the internet. So it's susceptible to some of the same things that websites are as far as going down and stuff like that. But What this is doing is setting up a machine or like a compute instance, more accurately, a compute instance that will host this REST API. So you can give it whatever name you want. This model supports no code deployment. That's great. Nothing to go along with it, deployment assets to go with it. So when I did that, I haven't checked this out yet, but we are about to find it, figure it out. Go to endpoints. It should have deployed my endpoint. I was doing that during break. So there's my endpoint. I called it crypto overall history prediction JB. Looks like it's still loading. Or no, healthy. Yeah. So let's go ahead. And healthy is a sense that, Brenda, that's what Brenda was asking about. Healthy states that the service is healthy and my endpoint's available. So the REST API is available to connect to. All right, so let's go ahead and test it. This demo is actually working out pretty well. I thought this was my worst one too. Like, no way this is going to work when I get here. Because model is still running too. Import data, input data to test. Okay. So watch this. We're going to leave all the rest of them 0. And since we know cap overall perfectly predicts cap, we'll put 9990 there. It should give us a test result of 9990 is what I predict. Oh no, it didn't. What? I'm surprised. Okay. That's the result that it gave me. It returned the result on the cap prediction. I put in cap overall in 9990 and it gave me 25,000. So it must actually be some like scaled version of the cap variable. So what if I do
But this is supposed to be for feature cap though, right?
So it's like, yeah, so you could put these in here. So you could in theory put into like today's whatever this information might be, right? So
What I'm saying is that if it's for feature cap,
overall,
the overall cap may not matter.
Well, if you want to predict something, yeah. So this is basically you're like putting in an observation, and like say you predict the cap overall. How would you do that? It basically returns. It's not quite a predictive model and saying like, okay, it's like 30 days out, right? Like, what is it going to be in 30 days? This is like a predictive model, like saying if your Bitcoin dominance is 0.06, your cap overall is 9. I have 9 digits there. 100 million. Cap percent changes 10%. You test it. What would you expect your cap to be? Market cap to be? And that's the result that it gives. So question is, how useful is that model? I don't know, maybe not that useful. It's not that like predictive of the future. When I think about it in retrospect.
So we
You
could
could put, if this was working, you could, like, here you go. So if you take out cap overall, say Bitcoin dominance got the 0.7, and some of your market cap percentages change that much, then what would you expect the total market cap to be?
So we took.
It's not like the future. cap that much. It's just like, if you got to these, what would you expect? What would the expected cap value be? So
We
in
were using the
retrospect,
housing
like,
market
not
data.
that predictive. Although you could use a regression model to predict into the future. Say, in 10 days, you expect this change to be a certain amount, this change, and Bitcoin dominance to this. Say you expected these in 10 days, then in theory, that would be your cap, market cap in 10 days. Does that make sense?
Yeah.
It's more of like a calculator. If you like enter these variables and you're like, what do you, based on these variables in history, what would you expect the total market cap to be?
So we were using the housing market data from sklearn in our last two classes.
Yeah,
So we could take something like that
yeah,
and the models we built for that and just throw that data, not even the model, take the data set, go through this and see how it did compared to some of our models.
yeah.
That'd be cool. See how Microsoft is comparing how
So, yeah,
Good.
and run through all of them and see if it could beat your prediction. That's one of the good things. It's like a data scientist friend because you don't have to churn through all those models yourself. It may take an hour for machine learning studio to do that, but how long would it take you to do that yourself? A week?
Yeah.
Maybe if just running all those different models, unless you already have like a library set up, which sklearn, they may, scikit-learn may actually have some set models that you could run through.
That's what we were doing. We were just running through a couple of set models that they had, that we were going through as part of the class. But
It's probably not really actually. The predictions that you get out of it aren't that much better in this, but you could be surprised. And sometimes those predictions on, if it's like on big numbers like market cap, the small percentages in variance can make a big difference depending on what you're doing. So
yeah.
You can tend to overfit a little bit some models, but that's part of your model statistics too. You have to just look through it and say, does this like model make sense, right? But this is a very cool tool to do that. We tested it. It looks like the endpoint works. Somewhere around here too, I wasn't paying attention, but he was able to get Python code for this. Oh, here we go. If you go to consume, here's your REST API endpoint. Excuse me. There's your Python code. Pretty sweet, right? I think so.
Yeah.
Saves me a lot of work. That's what these integrated platforms are supposed to do. So basically, this is the last step in what we're going to cover in this class. This is basically like from start all the way from like sourcing your data into the data lake and using storage and compute in Azure, and then Synapse Analytics to do analysis on your data and model your data. And you could even use Spark for big data processing. Use that data in Machine Learning Studio, create the models, feed it back into Azure Analytics, Synapse Analytics, and then produce it in Power BI. You have both the endpoint for your programming services, your systems or your programs, and then you could also do it in Power BI, which is the essence of all of that is what we're going to put together for the final project. So pretty good introduction in the final project. That's why I wanted to go back through everything and just make sure on Monday we have it all from start to finish, and that it's clear, like the homeworks are clear, everybody can do everything, and then the final projects is clear and what steps we want to take. So I actually have a little bit of work to do on that myself. So no homework for this week because it all ends up going into the final project anyway. So it's going to bring it up. I don't have the final project in this slide. And I'll give everybody time to finish this final project. But the homeworks have also been leading up to this final project, the examples and homework. So I owe everybody a couple of examples too. Those 2 examples that didn't have sound while I was recording. Class project. So I've started to sketch out the class project. So it's the same, predicting Bitcoin's future price. It'll be a little bit of everything. It's setting up the user account from Live Coin Watch. It also goes from the last class that we did where we started to add those REST API endpoints into Synapse Analytics and then feeding that data into the MySQL tables. So I put some new code out there in Slack today, SQL code to build the tables that you need. So saving everybody a step, but taking what we did partially from the data lake and started to build those tables and then automating it using the API endpoints. So we have 3 API endpoints for that. So then using Data Factory to parse those files and put them in the MySQL table. Once you have those in the MySQL tables, it becomes a fairly easy data source to use within Machine Learning Lab. So then the final step of that would be to put those results in a Synapse Analytics pipeline, and then, well, deploying the model, putting those results in a Synapse Analytics pipeline, and then monitoring those results in Power BI. So I also need to go through this over the next few days to like really lay this out and make sure like the homework leads up to it. I like give you the breadcrumbs to do it, and the like path is clear from start to finish. But that's a heads up on what the final project is. So really, once again, comprehensive of all the steps in between and making sure the instructions are clear to everyone. How I want you to take a look at it and build it from start to finish. Does that make sense to everybody?
Yeah.
So if nothing else, like you have all these videos and at least you have like a working pipeline from start to finish that you could always refer back to as like kind of your final project or gift to take away from the class. Practical application and gift, you can say, I did it. I built like a analytical pipeline, machine learning pipeline from start to finish and used REST APIs to do it. Which is
And I'm
what
sorry.
the cloud.
Did you say when it was due?
I'm gonna make it due the week after next. I'll give everyone 2 weeks to work on it.
Okay, awesome. Thank you.
That's not a problem for me to do that. I need to still catch up on all the other grading team. I'm behind, but I've been focusing on putting together the content of those classes and trying to make it the best I can. So I owe everybody quite a bit before Monday, but still working through it. So this was an opportunity for John C. or anybody else to ask questions about homework or anything else they want to cover in class up to this point?
Let me pull it up.
Stay till 9:30 for everyone here. And John, even if you want to share a screen, I could pass the
Do
stage
we
to you.
want to go offline, off the live stream for doing that, or?
Yeah, let's go ahead and wrap it up. That's fine. We're running out of space on StreamYard too, so we need to shave the minutes here anyway. So I'll do the outro here.
Thanks, Jeremy. Have a great night.
Let me pull it. What's that?
Have a great day.
There's a famous tagline from somebody. Not like good night and Godspeed, but there used to be like a news anchor
Johnny
said something.
Johnny Carson.
Johnny Carson did too, right?
Yeah, his
I can't
anchor. He used to say that one thing too.
I was thinking like Tom Rather did something like that. On like they used to have that weekly news. You like wait so long ago that I'm just old enough to remember it. They'd have like the nightly news,
Right.
like for years. They'd have Tom Rather on it. And he said something at the end of those things. All right. Anyway, to recap class 5, or well, we're class 6. Okay. To recap what we covered today, machine learning and artificial intelligence services, they both come as software and platforms as a service. Software as a service tends to come in APIs in the form of REST APIs or real-time APIs, or libraries that you can use in Python and C# or other languages to be able to create your own models or use existing models. Platforms are more of the platforms as a service, analytical platforms, and machine learning and AI. Those are more like Azure Machine Learning Lab that we learned tonight, and the other platforms have some of those. Those are all inclusive. Machine learning, data science tools that you need to be able to manage these models from their data and the creation of them all the way through deployment and maintenance. Those are the all-inclusive platforms and highly integrated platforms, such as Microsoft Azure and Microsoft Azure Machine Learning. So the Azure AI and ML service, he said why, what is, and why Azure Machine Learning. It's just a benefit of really that it's like a lot of these platforms, the all-in-one platform and collaboration and integration and being able to share between data scientists and data engineers when creating these models makes for a smooth handoff, plus all the tools are just right there in one spot instead of having to do all these things separately is a huge efficiency gain. Azure ML components and workflows, we saw the components of it. Those, I think, are 5 different components, really similar to other Azure platform services. And then a general workflow from start to finish, very similar to the workflow we've talked about here in class, from systems to data lake, the data integration steps, to Synapse Analytics, into Machine Learning Lab, and out to Power BI. And then last, we did an example of Machine Learning Studio and model building and deployment. So that's our class for tonight, Omaha Data Science Academy. I don't have a tagline for this, but better luck next class.
And that's the one.
We'll see you. This is basically the last class in this series, going from start to finish. We will finish up with working sessions and final exam, and Then do some on the final class on some of the topics we'll consider. But this wraps up most of the content for the class, and happy to do so as your teacher. So appreciate everybody, and signing off for class 6. It does make that transition easier if you just have like a tagline there. I get it. You just know what you're gonna say. Okay. I think that I stopped. Did I stop that?
It says live still.
That's it.
Dang. I ruined it. Edit the last minute out. Signing off. Okay.